almost let it slip.
No.
Woo, that was a close one.
No, come on,
You
Michelle.
were so close.
I'll get you one day.
No, you
Like a
won't.
supervillain. Supervillain.
Were we supposed to continue?
I do.
11.5?
We were done.
Oh.
I should have my friends.
You can. I'm still working though, because you're supposed to have already done it.
Because I was laughing because we started and everything. I don't know.
Pencil.
Yeah. Yeah, okay.
Sums and differences of radicals. Okay.
It's been
Sums
sharp, and I just kept
mean
it 'cause you're-
add. Differences means subtract. Okay. So here we go. You're not really
You better not be human.
adding. I'm not really human. Adding and subtracting. I'm not human. Some
She's
people
an
would
alien.
agree to that.
She's an alien. She's an elephant.
They don't have a name for it yet.
That's mean.
That is mean.
No, because the elephant's over there.
Calling me fat. All right. You're not really adding and subtracting. What you're doing, shh. You will be, hey,
Yeah.
you're going to combine like terms. Okay, this is the same as like radicals. Okay, so you have done this multiple times, combining like terms, okay? Now you're combining like radicals. And if you're sitting there saying, I don't remember what she's talking about, I'm about to give you an example. Adding and subtracting really, in my Algebra 1 class will tell you, even the honor students, this is way easier than dividing radicals, which is what y'all did last Friday. Okay? Dividing radicals is what y'all did last Friday. And it's, I mean, in y'all's, and that was another thing. They have a test over this stuff today. And we were reviewing. And I told them, I said, y'all, quit crying about the dividing. I said, 7th grade just got through doing dividing, and they're not crying about it.
Yeah.
And they're like, really? And I said, yeah. The difference is y'all's dividing way different than theirs, but they don't need to know that. I just made them feel silly because they're like crying about it. Don't have too many on the test.
I don't think I was.
What? In
Crying about
8th grade?
Oh, I thought you were talking about 6th grade.
Oh no, 8th grade. They were all crying about it, except for maybe Taylor. Okay, so here's an example. Oh, Gabby gets stressed out. She even texted me over the weekend about them. They can be stressful. Okay, so what you're going to do when you're adding and subtracting radicals is you're looking at the radicand. Okay? That's going to be your like terms. You know, where I set up here, your combined like terms or like radicals. You're really looking at the radicands. Okay? And this is what you're going to be combining if they are the same. So these two cannot be combined. Can't be combined. Not same radicand. Okay, they can't be combined, not same radicand. However, if I were to do another example, 4 times the square root of 3 plus 2 times the square root of 3. Now, notice that the radicand is the same. I'm so sorry.
Cool.
I can't do anything about that.
Is that fun?
It was a pun.
Yeah, it was a fun.
All right, so notice the difference. This is a 5 and 2. This is a 3 and a 3. The 3's are the same, so therefore you can combine. That's okay, I can pause. They get paid to be happy. They get
You
paid
get
to be
paid to
happy.
suffer and teach kids all day.
I get paid to not do a whole lot, but no,
Sit
I
at your
do it
desk and
because
talk
I
all
love
day.
it, and I'm actually gonna miss y'all very much. Okay,
Yeah.
What's this next to?
I'm gonna. Miss Lawrence pointed that out. She goes, "How are you gonna handle not being in the classroom? Like when you become administrator, you're not in the classroom with your kids having these talks and laughing and these inside jokes and stuff that we've got that only our class knows." And it was like, it hit me. It's going to be hard. I'm going to miss that.
And
It's
technically, we are, us in 8th grade are your last, technically
Yeah.
7th grade has always been your homeroom, but 7th and 8th this year is your
Yeah.
homeroom. So
That's
we
gonna
are the
be it.
very last class at your homeroom.
Yep.
Never forget us.
I won't. I'll never forget my first class I ever had, and y'all going to be my last one. So it's going to be kind of bittersweet.
Or 6th grade. They were so
Okay.
close.
They're so close. Okay. All right. So anyway, when you have the same radicand, now look carefully. We're going to add, because there's a plus sign. We're adding the 4 and the 2, which becomes 6. The radicand stays the same.
So you can add the thing on the outside if
Yep.
they're not the same?
Yep.
Oh, okay.
Okay. So the radicand stays same. Yes.
So, if you cannot add them, do you just leave it how it is?
That's right. Like, for example, right here,
Yeah.
this one right here, this would be the answer. That's a very good question.
Oh, that's easy. We can do the ones that's just-
Yeah. Yeah. If you can't combine them, then that's your answer. Okay, that's what we're doing today. So the steps for when you're doing this. The first step, and this is very important, you're going to simplify
Use a pen.
each, or hurry up and sharpen. Simplify each radical. And y'all remember how to do that. That's the factor tree and everything, right? Hello?
Huh?
Simplify each radical. That's that factor tree and everything. Remember?
Yeah.
And then 2, combine like radicals. Simplifying basically means factor tree and such. So I'm going to write that. Factor tree and such. And such. Just in case you hit a brain fart and say simplify. I don't remember what that means. Oh, yeah, factor tree. I get it.
Factor tree and such.
Factor tree and such. See, you'll remember that. For example, they're not going to be as simple as this in the beginning. You might have something like this.
How dare me.
We can't do it.
Well, wait. What's step 1?
Simplify each radical.
Factor tree and such.
Yeah.
So we're going to simplify
Oh, gosh.
each radical.
So that's only with subtraction.
No. That's it. Okay, now look up here. Can we simplify the 5 and the 2?
No.
Kelly, can I simplify the 5 and 2?
No.
They're prime. The 3 and the 3? They're the same, so you can combine. How about 8 and 72?
They're both not prime.
That's right, they're both not prime. So you absolutely can simplify them. It has nothing to do with the subtraction sign. You're just making sure, step 1, you simplify. That's what you're checking. So 8 would be 4 and 2, and 2 and 2. So you write down your prime factors, just like we've been doing. We circle our pair, underline our leftover. So then the square root of 8 then becomes what, Atalia?
2 to the second power? Or 2 to the power of, to the,
No power.
not the power, the
2 times.
2 times the square root.
There you go. Very good. Very good. So 2 times the square root of 2. Very good. Minus, okay, now we do 72, Atalia. 9 and 8. And that's, of course, 3 and 3. 4 and 2, 2 and 2. Okay, so then we write these out. And please be careful. Make sure you circle. Last night when I was doing all these notes, I actually left out one. And I caught it because I looked over my work before I started circling. I was like, oh, there it is. Okay.
See, actually, I just wrote 5 instead of 3, so it looked like 3 was 5.
Okay, so now that you have these, Atalia, what would it be? What would this look like now?
Oh, well, do I have to say 2 times 3?
Yes, say it. So 2 times 3
3
goes on the outside.
times the square root of 2.
Very good.
Which is 2 times the square root of 2 minus 6 times the square root of 2.
Okay, so pause there. I need Joseph and Kelly, do y'all see what we did?
Yes.
Yep.
Any questions?
Oh.
Okay, Atalia, since you've been doing this, I'll let you finish. Can we combine these two terms? Why?
Because they have the same range.
Because the radicand is the same. So then
Not radicand.
it's going to be one of those days I can see. All right, so Talia, 2 minus 6 is
-4.
times the square root of,
0.
no.
Oh, you combine, so you do add them? No, 2.
Ah, look right here. You're right, she's right. We don't change the radicand, the radicant. So there is our answer. Does anyone have any questions? Yes, ma'am.
What happens if the radicand is the same?
Is this right here? If the radicand is different, then you cannot combine, and that's your answer. We'll do an example like that. Joseph, do you have any questions? Okay, be very careful to make sure you remember positives and negatives. All right. Let's do another.
Can I do it again?
No. Joseph, I'd like for you to do this one. No, we're not doing that. All right, so I have 4 times square root of 24 plus the square root of 54. So Joseph, you tell me what to do. Well, that doesn't matter right now. First thing you need to do, what's step 1? Okay, so what am I simplifying? That's right, 24 and 54. Okay, so 2 numbers that give me 24. Okay. And then we have 2 times 3, and then 2 times 2. So I'm writing out my prime factors and crossing out when I do them. What do I circle? And I underline the 2 and 3. So, do you remember what I do? How do I set this up? Okay, so I have 4, because we got to remember to include that, times what? What goes on the outside?
2.
Just 2, that's right. So the circle part goes on the outside with that 4 times the square root of 2 times 3. Right? So let's go ahead and finish that off. What's 4 times 2? 8. Times the square root of?
6.
Very good. I'll put another plus sign. Okay, so we have simplified, I want y'all to look up here. We have simplified 4 times square root of 24 and got 8 times 6. Does everyone see where we got this 8?
Yes.
We don't want to forget about that 4 that's out there. Exactly. Okay, just it's been a weekend, wanted to remind everyone. All right, so now let's work on 54. Joseph, what 2 numbers give me 54? 6 times 9. Was it? No, you're weird. So for this, we have 2 times 3, 3 times 3. Okay, so I'm going to write my prime factors. 2 times 3 times 3 times 3. Okay, so Joseph, what do I circle? A group of 3s, and I have 2 and 3 left over. So this didn't have an outside number, which is nice. So how do I write this?
So 3 on the outside.
Uh-huh.
And then 2 times 3 on the inside.
And then 2 times 3, the leftovers on the inside. I think really with you guys, because this is so new, the biggest thing is remembering which goes on the outside, which goes on the inside. So then this becomes 3 times square root of 6. All right, so Joseph, can I combine these two terms?
Yes.
Why?
Because the radicands are the same.
That's right. So then what do I get?
11 times square root of 6.
Perfect. 11 times square root of 6. The 8 and the 3 combine to give you 11. We are adding. The 6, the radicand, does not change. You just carry it over. Any questions? Yes, ma'am?
So if, for instance, let's say it's 8 times the power, or the whatever.
Square root, yeah.
Of 6. 3, and then plus 3 to the square root of 8. Would the top part just be your answer?
Exactly. In fact, Kelly, you're doing this one. And you'll see this. All right. So now I'm going to have, and you may want to write small, 3 times the square root of 12 minus 2 times the square root of 8 plus 3 times the square root of 32.
Oh my god, that's a lot.
All right, so Kelly, sit back, be an investigator. Look and see what you got first. Notice, okay, I've got a 3 here, 2, 3. I got a minus and a plus. And, okay, the radicands, 12, 8, and 32, none of which are prime, so what do you need to do?
So first, grab the 12 and put it in a factor tree, and do 6 times 2, 6 times 2 times 3.
Okay.
6.
And then so we write down our prime factors. What do I circle?
This pair of 2s.
And then the 3 is left over, so how do I rewrite 3 times square root of 2? 12.
The 3 that was outside the 12. You pull it down and times 3 again.
What? What goes on the outside?
All the pairs of 2.
Pair of 2 times square root of 3. So then what does this give you?
6 radical sign 3.
Times the square root of 3. All right. Okay, so she completed that. We've simplified it and brought it on down. See how nice and neat that is? I brought down my subtraction sign. Now we have to do this one.
So 8, 2 times 4.
And then
Yeah.
2 times 2. All right, so I have 2 times 2 times 2. What do I circle?
The pairs of 2.
So how do I write this?
Oh dear me. Okay, so you put the 2 on the outside of the radical along with the other 2.
Times the square root of
2.
2. Which then gives you?
4 radical sign 2.
Sure.
I speak wrong.
That's okay.
I speak wrong.
You speak different. All right, so now what do I need to do?
So you want to grab the 32 and put it in a factor tree.
Okay, I'm going to do it right down here.
Yeah.
What numbers?
8 times 4? No. Yes. 8 times 4.
Okay.
And then 2 times 2 equals 4. 8 times 4 equals times
4 times 2.
And then 4 times 2 is also 4.
No, 4 times 2 is not 4. 2 times 2. Okay.
I don't like
Sorry,
chicken.
Kelly.
I know. You have trouble when you're on the spot. Okay, so I've got it all written down. What do I circle?
Okay. So you circle 2 pairs of 2.
Yeah.
So then what goes on the outside up here?
3, 2, 2, and then inside the radical sign is a 2.
Very good. So then 3 times 2 times 2 is?
12.
All right. Now, do y'all see this?
Yes, ma'am.
Yes.
All right, so Kelly, look at your 3 terms.
Okay.
Which ones can we combine?
The 2's inside the radical.
Okay, can they be combined with this?
No.
So we're combining these right here, correct?
Like
Okay,
Okay, so then this doesn't change, so I'm going to go ahead and bring it down. What does this become?
that becomes 8 outside the radical sign 2.
Positive 8 times the square root of 2. And there you go. We can't combine these two, so that's your answer. Now, there are times, if you were to do IXL, they are going to want you to put these in descending order. So they're going to want you to put it like this. Because, see the 3 and the 2? They're going to want you to do 2 and the 3. But I don't care. You can do that. Are there any questions?
Yes.
What?
Wait, no.
That's funny.
Do y'all, do y'all understand what y'all doing?
Yes.
Isn't too bad, is it?
Oh, wait, no, I do have a question.
Yes.
Okay, so what if we have one that's like, that there's one of the radicans is prime and the other one is not prime? So prime and composite.
Okay, let's see if I can find one for you.
Doesn't that mean you just do the one that's not prime, put it in a factor tree, and then the one that is prime, you just put it how it is?
I think so.
If it doesn't have anything outside the radical sign.
Just making sure. So I'm not sure.
So, yeah, if you just simplify what you can.
Can we do an example?
Of one that's prime and one that's not?
Yes.
Didn't we do that on one
One that's prime and one that's composite. Could we just make one? Or you just
Well, it doesn't really matter. You're just going to simplify whatever you can. Are you talking about the radican?
Yes.
Okay, I can do, let's open up your books. I got one. Page 477.
Oh, dang it. So,
Okay, so the top part you get, you're just going to combine like radicans, okay? So part A, you'll be done in no time at all. Let's look at 11, things that are different.
Oh, gosh.
11 is 2 plus 8 times the square root of 4. Okay, so this right here does not have a radical with it, square root, so it's just a regular whole number.
Couldn't you make it 2 times the square root of 1?
No, you just don't need to. So, but here, can I simplify this? That is 2 times 2, right? So 2 times 2. That's all I got. I circle it, so where does it go?
On the outside.
Okay, so it goes on the outside. I'm going to rewrite my problem. 8 times 2. Do I have any leftovers?
No.
So then do I have a radical sign then?
No.
What's 8 times 2?
16.
What's 2 plus 16? There's your answer.
But what if you have one that has a radican that's not? That's prime. And then it's composite.
Okay, well, let's look at 13. Does anyone have questions on 11?
No.
I never knew that.
Okay, but do you see how this went?
Yes. It's only 7.
Okay. How about if I have, let's look at 13. 3 times square root of 5 minus square root of 45. Isn't that kind of what you're talking about, Talia? Okay, so this 5 is prime, correct? Joseph and Kelly, do y'all see that? So do I need to simplify it? No, I can't because it's prime. Now, 45 is not prime. They're not the same, so I do need to do that one. So what two numbers give me 45? And then 3 times 3. So I write 3 times 3 times 5. So Talia, what do I circle? And that's left over. So how would I write this?
3 times the square root of 5 minus 3 square root of 5.
Y'all see that? So there, you had one that was prime, one that wasn't. So we went ahead, simplified it. So 3 times square root of 5 minus 3 times square root of 5 gives you what?
Square root of 5?
Nope.
Just square root of 5?
Nope. This is a whole term.
Right.
So this whole term,
Minus the other. 0 times square root. That's the same thing. What?
0.
That was 0 times the square root.
No, it's just 0 because this is identical to this. So it's just 0. If you did 0 times the square root of 5, what's 0 times anything?
1. 0.
It is 0.
Isn't that one thing that we learned? It's 1. Remember that? What was that thing where something as fractions, something like that? Something times 0.
Now look, exponent of 0
Yes, that's what it was.
gives you 1.
Yeah.
Okay, but anything times 0 is 0. So 3 minus 3 is 0. We bring down our radicand. 0 times that is 0. So your answer is 0. Any questions?
Doesn't it just cancel each other out?
Yeah, but do you understand how this works? 3 minus 3 is 0. You bring down your square root. This is really, we're multiplying. 0 times this is 0.
Are we going to be doing like 27, 29, 30, 32?
No. So you are doing page 477. I'm setting you free.
That is
And you're doing numbers, let's see.
What's for lunch? Nachos.
2 through 26 even. Due Tuesday.
Is that it?
Yep. So tomorrow we do cubed roots. And then we start a review Wednesday, Thursday. So your test, I don't even know if I'm going to, no, I'm not going to do that too. I'll have it on Thursday. I'll probably have it on Monday.
Yeah, you're the restroom.
Yes.
You mean have it on we're not going to have it on Friday.
No, you have, what's it called? Field day.
Oh, that's Friday.
So test is going to be Monday whether I do cubed roots or not.
What is that?
You'll see tomorrow. All right.
But 14's a lot.